Hello there, this is Mr. Sutton bringing you the IM23 Honors 3-9 homework answers on central angles and arcs. For number 1, we want to find the type of arc and the measure of the arc for arc BC, that's this arc over here. So this takes up less than half the circle, so this is a minor arc. And since we have a central angle here of 70 degrees, that means this arc is going to be the same degrees, also 70. For number 2, we want to find the type of arc and the measure of the arc for arc DC. That's this arc over here. Since this is clearly less than a semicircle, this is a minor arc. And for the measure, well, we know that we've got 180 degrees from E to B here, because this is a diameter going across the whole circle. So that means that arc DC has to be whatever's left over when you subtract 40, or 45 rather, and 70 from 180. Well, 45 plus 70, that adds up to 115. 180 minus 115 gives us 65 degrees. For number 3, we want to find the type and the measure of arc DB, this arc over here. It's less than half the circle, so that's a minor arc. And we just have to subtract 45 from the full semicircle that we have from E to B. So that's going to be 180 minus 45, which gives us 135 degrees for arc DB. For number 4, we're trying to find the type of arc and the measure of arc for AE. Since it's less than half a circle, this is a minor arc. And for the measure, AE is going to have the same measure as BC because its central angle is the vertical angle of arc BC. Well, arc BC has a measure of 70, so does arc AE. For number 5, we want to find the type of arc and the measure of the arc for ABC. So ABC, we have to go ABC, so it's this arc here. Since this is formed by a diameter, this counts as a semicircle, which means it's automatically going to be 180 degrees, half a circle. For number 6, we want to find the type and the measure of arc ACD. So ACD, this is going to be a major arc. We've got ACD, so that's more than half a circle. And then to find the measure of that, well, we've got the semicircle here, ABC, plus whatever arc DC is. So in general then, that's going to be 180 plus this extra little arc in here. We found in an earlier problem that this was 65. If you don't believe me, you can just subtract 45 and 70 from 180 and you've got your 65 in here. So that's going to be 245 degrees. For number 7, we want to find the type and the measure of arc EAC. So this is EAC, this big arc right here. To do this, first off, we know that this is a major arc because it's more than a semicircle. EAB would be a semicircle, and we're going beyond that, so this is a major arc. Now to find the measure, we have the semicircle EAB, formed by this diameter, plus whatever arc BC is. Well, we know that EAB is 180 degrees because it's a semicircle. BC we're essentially given, it's this 70 degrees here because of the central angle. So we've got 180 plus 70 comes out to 250 degrees. For number 8, we're trying to find the type and measure of arc AD. That's this arc here. Since it's less than a semicircle, that's going to be a minor arc. And for the measure, we've got the 70 degrees with this vertical angle that arc AE is, plus another 45 degrees here for arc ED. So that's going to be 70 plus 45 gives us 115 degrees. For numbers 9 through 18, we're given this circle in which MQ and NR are both diameters, and we want to find the following things. So for number 9, we're doing arc MN. That's this arc right here. That has a central angle of 70 degrees, so the arc is also 70 degrees. For number 10, we want the measure of arc NQ, this arc here. Now NQ together with MN makes up a whole semicircle. So to find NQ, we just have to do 180 minus the 70 that we've already used up here. So 180 minus 70 gives us 110 degrees. For number 11, we want the measure of arc NQR. That makes up a whole semicircle since NR is a diameter, so that's 180 degrees. For number 12, we're finding the measure of arc MRP, this big arc here. So we've already gone a whole semicircle by the time we get from M to Q. We just need to go another 30 degrees. So that'll be 180 plus 30 gives us 210 degrees. For number 13, they want the measure of arc QR, this arc right here. Now what we can use on this one is the fact that these vertical angles, this angle and this angle, are going to be congruent. So we know that this angle in here, this central angle, is really 70 degrees, meaning this arc is also going to be 70 degrees. For number 14, we want the measure of arc MR. This is a piece of a semicircle. We've already used up 70 degrees of this semicircle in this arc over here, so 180 minus 70 gives us the 110 degrees for that arc. On number 15, we want the measure of angle, or rather arc QMR. So this is a very big arc. This is pretty much the entire circle except for arc QR. Now arc QR is going to be 70 degrees because it's going with this central angle which is vertical to this 70 degree angle up here. So if we just do 360 minus 70, we'll have our arc. So that's going to be 290 degrees. For number 16, we want measure of arc PQ. That's this little cute arc in here. That's across from 30 degrees for the central angle. So that's also going to be 30 degrees. On number 17, we're trying to find the measure of arc PRN. So for this one, the way I looked at it, we've got this arc, which we know is 30. This arc in here, which we know is 70 because it's across from the central angle, which is the vertical angle, 70 here. And then we also have another 180 degrees for this semicircle. So 30 plus 70 plus 180 gives us a grand total of 280 degrees. For number 18, we want the measure of arc MQN. So essentially, we want the whole circle except for this little arc in here. So we can do 360 minus 70 to give us 290 degrees. For number 19, we want to solve for x in this circle. The key on this one is realizing that this arc and this 45 degree arc have to be the same because their central angles in here are vertical with each other. So we can write 9x equals 45. Dividing by 9, we have x equals 5. For number 20, we're trying to solve for this x value in here. The key on this one is realizing that this 116 degree arc, its central angle here, is vertical with the combination of these two central angles. Now these angles are both the same, which is what this little arc symbol in here is telling us. So that means that this central angle up here has to be 14x plus 2 as well. So if we do 2 times 14x plus 2, that whole angle has to equal this whole angle, which is to say it has to equal 116. So we've got 2 times 14x is 28, times 2 is 4 over here. So we have 28x plus 4 equals 116. Subtracting 4, we've got 112 over there. And dividing this either calculator or by hand, this is going to come out to 4. Because 4 times 25 would be 100, and 4 times an extra 3 on that would give us the 112. For number 21, we're trying to solve for x. Now, all the information we're given is all contained on this one semicircle in the circle here. We've got 45 degrees for this arc, a central angle of 65, which means this arc here is also 65, and then we have this other arc here, 23x plus 1. All three of these things have got to add up to 180 because they all make up the complete semicircle on that right side there. So setting them equal to 180, combining like terms, we've got 23x plus, let's see, this will be 66, plus 45 is going to be 111. Subtracting 111 from both sides, that's 69. And dividing by 23, we get x equals 3. For number 22, we're trying to find the value of x here. Now, the key on this one is realizing that they've actually given you, one way or another, every single arc in this circle. This central angle means we have an arc of 5x plus 15. These two central angles are both 70, so these arcs are both 70, and then they gave you the arc 155 over here. All of those arcs have to add up to 360 degrees for the whole circle. So combining like terms on the left side of this equation, we've got, let's see, 155 and 15 is going to give us 170, plus another 70, that's 240, then 310. So we have 310 and 5x equaling 360. Subtracting 310 from both sides, that's 5x equals 50. So then x must equal 10.